Why, hello there once again, YouTube. My name is Ben Ferriolo, and I'm dedicated to the responsible and accurate seismic monitoring of volcanic and tectonic hazard areas. First off, if you have not already, please bookmark my website. A link is provided under my email address in the description box below. Go check it out now if you want. It contains a great deal of information, including how to understand the many different types of plots and charts people use, how to find, access, and analyze seismic data, and it also contains hundreds upon hundreds of seismic plots and images regarding a great many seismic events and earthquake swarms on many different pages. Mainly the earthquake swarms at Yellowstone, though. But still, I've got many other events on there as well. Even some plots of the Mayotte event. Remember the Mayotte event that occurred on November 11th, 2018? If you want to see those, go to my website, Seismic Events 2 drop-down menu, and click World, and it should be the first event on there. In this video today, I'm going to show an earthquake that occurred in the North Pole, very close to the North Pole. An earthquake swarm that occurred at Yellowstone. Wasn't major, but still, it occurred, and I gotta talk about it. And Steamboat Geyser did erupt for the 11th time of 2019, which is actually, the 43rd time since 2018, since it reactivated in 2018, excuse me. 43, right? Let's see, 32 is the new record. 32 eruptions in 1 year, plus, yeah, so that's 43. Alright, so let's go check out something real quick first. Okay, this is the past 3 hours of ETS tremor on the ETS tremor page. Notice we have a little bit down near the, actually that might be background noise, I don't know. This is the lower accuracy. This higher rate, lower accuracy version of PNSN standard tremor product updates hourly, but is known to contain significantly more faults detections. Usually the faults detections are standalone, and there's like one or two. Like for example, this could be real or this could be a faults detection. But usually the faults detections are not clumped into a bunch like we see down here. This is usually real. Starting in, early March of this year, which we're still in March actually, there was an ETS tremor event that did kick off. It wasn't too crazy. We definitely had many bigger ETS tremor events. But the interval has changed. And if you want to go to Scott's new channel called the NW Geology Guy, there's a link to his channel in the description box below. He also talks about that as well. Personally, I believe Scott from the NW Geology Guy, he's a little bit more knowledgeable on this stuff than I am. I'm more of like a volcanic seismology guy, but I'm still learning. You know, but we, apparently, it's supposed to do it every 12 months, or is it 14 months? I believe it's every 14 months. Correct me if I'm wrong on that. Every 14 months or so, we do have an ETS tremor event, but it hasn't even been 12 months yet. So this one's a little bit early. And this is just the past 3 hours. As of 12:19 p.m. Pacific Time, March 26, 2019. Let's go to the past 2 days, the past 48 hours, 15.7. So it is much lower than it was a few days ago, even maybe a week or so ago. You can see we did have a bunch down near the, the South Sound, near Olympia, Tacoma area. It did start right up here near the northeastern tip, actually, of the Olympic Peninsula. Went a little bit north, then went a little bit south, and then stopped. And then now it started back up again with 2 epicenters of swarming going on of this tremor event, occurring near Olympia and down just north of Redding, California, in Northern California. Don't know what this means. I don't know, but it's acting very weird. Usually ETS tremor continues, right? It doesn't just go off and on, off and on, off and on. I don't know. I'm not an expert on this, guys. I'm far from an expert on this. But I just noticed it's just acting strange lately. And it's early, too. It's early, but then again, it's not that big of a tremor event. It could just be a precursor to the actual ETS that is on its way. Let's go to the HVO webcams, shall we? As of 9:15 a.m. Hawaiian time, which would be 12:15 p.m. Pacific time, this is the shot of Kilauea caldera. We see a little bit of steaming along the Halemaumau crater walls, but besides that, that's pretty much it. It hasn't been steaming too much. We did see a little bit increase in steam output, primarily usually in the mornings and when it's a little bit colder. That might be normal. But in the last Hawaiian Volcano Observatory update, I was very disappointed. Very disappointed. They didn't state at all that the magnitude 5.5 was the largest to occur since the eruptions calmed. Because remember how early in March there was a magnitude 5.5, which I proved in one of my recent videos that that was the largest earthquake to occur since the eruptions calmed. No mention of it. No mention of it at all. I don't know why, but that's pretty much it. There's Halemaumau Crater within Kilauea Caldera. Now here we are at isthisthing.org/Yellowstone for the helicorder thumbnails for Yellowstone. Now, first off, you'll notice that Steamboat Geyser did erupt again. I will talk about that in just a second. I'll talk about that first, actually. And then notice, you can see some earthquakes appearing on multiple of these seismic stations around the Norris area. We'll take a look at those after the Steamboat Geyser eruption, or after we look at that. Let's go to monitorsize.weebly.com and go check out the most recent eruption. First off, do not forget to come to my website. Again, the link is in the description box below, right under my email address. And go to the Seismic Events drop-down menu, right here. You don't click it, you just scroll down. Notice, click Steamboat Geyser 2019 to see what I'm looking at now. But also, don't forget about Steamboat Geyser 2018, which shows all of these seismic plots and images regarding all of the steamboat eruptions that ever occurred in the whole year 2018. All 32 of them are shown on this page right here. Here we're at Steamboat Geyser 2019 to look at the most recent eruption. Why did I click it again? There we go. Okay. Here's a picture of Steamboat Geyser in the Norris Geyser Basin, if I can pan down. This is in the steam phase of eruption on March 16th, 2018, just a day after the first water hydrothermal eruption of 2018. Photo was taken by Benaz Husseini or something like that. Hosseini. Benaz Husseini. Okay, sorry if I said your name wrong and you're listening to this. Sorry, I'm really bad at pronouncing things. This most recent steamboat eruption shown here is the 11th eruption of 2019, which is the 43rd eruption since Steamboat reactivated in early 2018. Now, this recent eruption is likely the strongest steamboat eruption to occur in 2019, at least in regards to the amplitude of the surface waves. If you look at the stream gauge at Tantalus Creek, which I'm about to show in just a second, you would notice there was not a lot of water put out by this eruption. So how is the amplitude much larger than usual, but the amount of water output is even lower than previous eruptions? Let me know what you think. How is that possible, guys? That doesn't even make sense to me. So the amplitude is much stronger. Very possibly, guys, very possibly this is the strongest eruption of 2019. Still much weaker than the eruptions of 2018, but still the strongest of 2019 possibly. But it put out less water than the most recent eruption. Really? You know, Steamboat is still holding its near-weekly schedule and will most likely erupt again around April 1st to April 2nd, 2019. No, it's not an April Fool's joke. Will Steamboat remain active indefinitely? That would be very interesting. Very interesting. This 11th eruption of 2019, which again is the 43rd eruption since Steamboat reactivated in early 2018, occurred at 23:37 UTC on March 25th, 2019. Which is also 5:37 p.m. Mountain Time, same date. There it is right there. Notice, according to the amplitudes, this is the strongest of 2019, supposedly. And notice something. This is something I have not seen. Let's go down. Hold on. Let's go down. I have not seen this since, yeah, not on that one. I haven't seen this since 2018, actually, I believe. Let's go down. Nope, that didn't show it. Notice how on all these weaker eruptions of 2019, how the frequency, the dominant frequencies remain around the 10 to 20 hertz line. You notice that? And you can also see the dominant frequencies on the spectral plot right there. Notice that? Okay, let's go down. These are all the eruptions of 2019. Still seeing lower frequencies. Still seeing kind of lower frequencies. This went up to about 30 hertz. And a little bit higher frequencies because it's stronger. There seems to be a correlation between the amplitude and the frequency extent. Very interesting. And here's the third eruption of 2019, still kind of mid-range. This is a little bit higher. This is what kind of looks like occurred last night. And let's go down here. Okay, going to about maybe 40 hertz maximum. Let's go to the most recent. Right here, goes all the way up to about 45 hertz. A frequency range of about, let's see, here's the dominant frequencies in the spectra plot. There's a spike at 20 hertz, goes down, remains between about 25 hertz and 45 hertz. That's a much higher than what we've seen lately. Something has changed with Steamboat, but again, let's go to the current conditions at Tantalus Creek. Now, when read correctly, this will show you the amount of water discharged from Steamboat Geyser. Now, look at something. This is last night's eruption right here, right? Almost near perfect 90-degree angle right here. Almost perfect. This possibly is a precipitation spike. Notice how this spike right here, which is from the Steamboat eruption, occurred between the 25th and the 26th. That's because it occurred very near midnight, and this is in mountain time. So that means this one occurred near midnight mountain time as well, but from the 24th to the 25th. Well, let's see what we see. Previous day, so from the 24th to the 25th, let's go back. 24th to the 25th, let's see here. There's the 24th to the 25th, that's midnight for UTC. I'm not seeing anything. There's no Steamboat eruption. So, it is obviously very possible that Steamboat was, let's say, oozing water. You know, that is a possibility because the amplitudes are from the actual eruption. The force of the water and it records the surface vibrations from these Steamboat eruptions. Maybe it was oozing water. I don't think this is a precipitation spike though, because I've never seen precipitation spikes actually look like Steamboat eruptions, because that looks very similar to Steamboat eruption, doesn't it? We do see little ones here and there, but it is strange. I don't know. Maybe Steamboat was oozing some water and then it had its eruption last night. I don't know. But the seismic trace is not there on YNM for this right here. So this is up in the air. I don't know. See, this is why we need a webcam at Steamboat Geyser, guys. Who wants to see a webcam at Steamboat Geyser? Shoot me an email. I'm literally making a list, and I only have like 2 people. Seriously, I only have like 2 people on the list right now. We need more people to sign the petition, please! I really want a webcam for Steamboat Geyser. A live streaming one, not a stupid static cam. That would be nice. That would be nice. So, let's click right now. Go to right now. So, after the Steamboat eruption, which occurred near the UTC midnight, between the 25th and the 26th, let's go to Norris Junction. Here's YNR in the WY network. Notice how there was some swarming between about 4 to 5 UTC and about 9 to 11 UTC. So that was last night, actually, in the middle of the night last night, many hours after the Steamboat eruption, there was an earthquake swarm, maybe related, may not be, I don't know, but why don't we go take a look. Here are the latest reported earthquakes. So between 4 UTC to 5 UTC, they have none reported. They did not report any of the earthquakes to occur right here, at least to my knowledge. At least that's what I'm seeing. And you could obviously see it on multiple stations. There's 2 bursts. The first burst around 4 to 5 UTC, and the second burst around 9 to 11 UTC, right down there. And you can see it appearing on multiple stations, even on YMR at Madison River. Now it seems like both of these bursts, let's go to borehole 950. Now it seems like both of these bursts occurred most likely in the same epicenter. They're pretty much propagating away from their source, just like they should. I believe they are coming from the same epicenter. So let's go look here. Let's turn on terrain, shall we? We're at Yellowstone right here. There's Washburn Range. Here's Yellowstone Lake. It occurred right in this. Norris is right here, so it occurred just west of Norris. Actually, right at Holmes Hill, it looks like. Right at Holmes Hill. Let's see, Roaring Mountain, Norris Canyon Road, right there. So Norris, let's see, is that Norris Basin right there? Let's see. Let's see, I believe it is. I believe this is where Steamboat Geyser is. Click street. Norris Canyon Road, Grand, yeah, I'm pretty sure that's Norris. Let's zoom out. So these are the earthquakes they're reporting for the swarm. They are only reporting the earthquakes that occurred between 9 and 11 UTC. They're reporting a 0.6 at 5.0 kilometers in depth, a 1.9 at 8.4 kilometers in depth, a 2.3, oh no, never mind, a 0.9 at 2.3 kilometers in depth, a 1.3 at 7.3 kilometers in depth, a 0.9 at 4 kilometers in depth, 1.5 at 4.8, and a 1.5 at 2.2 kilometers in depth. None of these earthquakes were reportedly felt by anybody. That's not shocking. They're pretty small, but still they occurred. Now let's see what the closest seismic station is to one of these earthquakes so we can take a good look at this earthquake swarm. So what you usually do to see the closest seismic station reported by USGS, sometimes there are closer stations that are not labeled. You just go to origin, then you click phases, scroll down a little bit, click arrival time. Closest one was YPM, Purple Mountain. Apparently, but the other earthquakes did not show well on there. So we know it occurred somewhat near Norris, right? Basically between Purple Mountain, Holmes Hill, and Norris. Around that area, because just west of that. So why don't well, what's a good station we should use? Why don't we use borehole 950, since it's actually somewhat close. And it looks like as of the past hour, there were another two earthquakes. So let's download the data for borehole 950, shall we? Let's see, the 26th. So let's do the 26th at 00. Whoops. I am messing it up. My goodness. I am messing it all up. And to the 27th, I know it's not the 27th yet, even for the UTC date, but I like to do that just to top it off. Just to get the most recent data possible, borehole 950-EHZ. And then you scroll down, and you click this link. Did it download? Yes, it did. Let's check it out in the seismic program Swarm. Here we have the most recent data stream from borehole 950, which resides near YNR in the Norris Junction, south of Norris Geyser Basin. Or actually, was it like a little more southeast-ish? This is the most recent data stream since about 1700 Mountain Time on the 25th, which would be midnight for the 26th, 0 UTC. Let's turn persistent rescale offset overlap to 95. We do not need a filter because this is a short period station. Well, sometimes you can use a filter depending on what you're looking at, but right now we don't need one. Here's the first earthquake right here, which is just weird. Just very odd. I don't even know if that's an earthquake. Looks kind of like an explosion, in my opinion. Here's another one, very identical. I guess it is an earthquake. Okay, so we do see the Norris area, well, just to the west of Norris, did see some type of rapid-fire swarm, somewhat. But very small. Magnitudes were very small. Again, very tiny. Let's take a look at the waveforms real quick. No low-frequency events detected. Not detecting anything. Not much, actually. Remember, none of these earthquakes in this area were reported. I guess they thought they were too small. But then again, why wouldn't you report it? Even if you think they're too small. I mean, P and S wave arrivals, they look kind of hard, but they still should have reported some of them, guys. Let's go back to the spectrogram. Zoom out a little bit. Here's some more of the earthquakes. Yeah, I'm not seeing anything too major. Remember, this is just the first burst. We're just looking at the first burst right now. I see maybe a maximum of 4 events occurring. Yeah, that looks like 4 earthquakes right there. So it did have rapid fire characteristics, which does occur here and there, here and there. And then we had a second burst between 9 and 11 UTC. Going forward, teeny, tiny, 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 popping, popping, teeny, tiny. Very tiny. And then we see 4 events right here. Obviously, you can tell those are 4 tiny microquakes. Almost looks like it gets big, big, bigger, and then small, smaller. Kind of like something's approaching, right? Kind of gives that illusion. Sometimes the earthquakes do that. Very strange. And let's keep going forward. Not seeing any low-frequency events. There is a little bit of low-frequency background activity, but the amplitudes are extremely low. Extremely low, and that does not, to me, look like any type of harmonic tremor or volcanic tremor. It'd be much stronger, and I believe the frequencies would be much lower, in my opinion. Just my opinion. And then we see a larger earthquake here with multiple aftershocks. Let's take a closer look. Some strong surface waves at the end. Very interesting. I wonder, let's see, 928. I wonder if this is the deeper earthquake. Am I right? Am I right? Is this the deeper earthquake at 928? 928. Aha! Look at that. 1.9 at 8.4 kilometers in depth at 927.59, which basically is 928. Remember, this is a few miles away from the epicenter. Here's the epicenter of the swarming. Borehole 950 is right here, but we're still getting a good look at it. Still getting a good look. Again, this was the magnitude 1.9 at 8.4 kilometers in depth. And that's this one right here. Right there. Some dominant lower frequencies, but we should see that for the surface waves sometimes. Okay, so we did see a rapid-fire swarm, guys. We did see a rapid-fire swarm at Yellowstone. Let's scroll down. Nothing too major. Looky, looky. Look right here. As of, let's see, what would that be? That's 12:17 p.m. Mountain Time, which for us would be 11:17 p.m. Pacific Time, March 26, 2009. Oh, no, wait. No, I am wrong. Do not listen to me. I am wrong. I forgot. Swarm automatically sets this in Pacific time for me. The online web recorded charts for isthisthing.org and University of Utah, they have mountain time on the left. I forgot that I have Pacific time. So right now on my clock, it says 12:39 p.m. Pacific time. The most recent data stream, is 12:32. So that's only about 5-10 minutes ago, right? Very interesting. We did see another rapid fire swarm has broken out in Norris just in the past 30 minutes to an hour. Nothing too major again, guys. Nothing too major, but we are seeing an increase in seismicity at Yellowstone for sure. Just after this recent steamboat eruption, which was likely, in terms of amplitude, likely the strongest steamboat eruption to occur since 2019, the start of 2019. Keep going forward. Nothing too major, nothing too crazy. 600 amplitude count. Right there. Let's scoot in on this. These will probably be reported in the next hour or two. Let's see, what day is it? Is it Sunday? No, it's Tuesday. I am way off. Wow. It's Tuesday. I forgot. And as of the most recent data stream, back here, not seeing much. Okay, so the steamboat eruption again occurred up here in this area, right around 0 UTC, the 26th. Actually, it was 23:37 on the 25th or something like that for UTC. And then we saw a burst of seismicity between 4 and 5 UTC. So a period of calm in the middle. Then we saw another burst of seismicity between what? I'm actually going to say between about 8:30 UTC to about 10:30 UTC. And then just as of the most recent data stream, we do see another burst in swarming down here. Magnitudes are not exceeding magnitude 2.0, at least yet. But it is definitely something to keep an eye on. Definitely. Okay, so now that we're done with that, I want to go to the latest earthquakes in the world to see if anything has struck since I started recording. A lot of earthquakes down in California, some earthquakes up in Alaska. There's an earthquake up here I'm going to show in just a second. There were 2 earthquakes actually near North Carolina. Both of them in North Carolina, actually. Why don't we, let's see. Okay, I did not want to do Hawaii. Actually, in Hawaii, there have only been 3 earthquakes in the past 24 hours, with the largest being a 2.1 at 31.2 kilometers in depth. Yeah, definitely way too quiet for me, guys, especially after that magnitude 5.5. I don't know. You know, it's pointing to it. Nothing too crazy is changing right now, according to the GPS deformation. Oh, speaking of GPS deformation, I forgot to do that for Yellowstone. Here, why don't we go check something out? Let's see, Mount Hood. Looks like Mount Hood did have an earthquake today, guys. A magnitude 0.7 earthquake under Mount Hood at 0.1 kilometers in depth. I'll probably check that out in my monthly volcano update, which will be out in the next week or so. Then we had an earthquake up here in Washington, a magnitude 1.6 at 22.1 kilometers in depth. Most likely connected to that ETS tremor event that has been going on and off. Then far south in the Tetons, south of Yellowstone, there was a 2.3 at 6.8 kilometers in depth. Okay. Utah, Nevada, seeing normal seismicity. California, seeing normal seismicity. They're shaking all the time. Now let's go forward, shall we? North Carolina did see 2 earthquakes. 2 of them. Magnitude 2.6 and a magnitude 2.6. The most recent one was at 0.8 kilometers in depth, and the older one was at 4.4 kilometers in depth, occurring about, I'm going to say, what is that? That's about 12 hours. So about half a day between each other. So let's download the seismic data to the closest seismic station to this event. Let's click on the event page. If it will let me, come on, buddy. There we go. Thank you, USGS. Okay, so here's the first earthquake. Magnitude 2.6 at 4.4 kilometers in depth. 706 people reported feeling it! What? 706? Wow, that is a lot of people for a 2.6, guys. Wow, and they're very tightly constrained around the epicenter. Obviously, people around the area farther than the epicenter did feel it. But still, guys, wow. My goodness, 706, and then this one that is the same size only saw 321 people reported. Again, most being around the epicenter and slightly to the east. Okay, well, that's very interesting. Let's go to origin, and let's download the data to the closest seismic station. Go to phases in origin. Quick arrival time once. ETWSNC. Let's check it out in the program Swarm. Here we have the most recent data stream for the 26th. For WSNC in the ET network, I already turned persistent rescale offset 95 for the overlap for the spectrogram. Let's turn on the spectrogram first real quick. Let's scoot forward. Okay, first off, we see this event right here, which barely shows on this. Actually, no, wait, it's right here. Never mind. Actually, let's do a frequency extent of 55 hertz. Well, let me do 55. No, it only let me do 50. Okay, that's fine. Right here, look, see how this looks like. If you were just to look at the helicorder, you'd be like, oh my god, some type of tremor. Guys, we got a tremor in North Carolina. Well, just hold on just a second. Notice how when you look at the spectrogram, it starts with a strange burst of high-frequency activity and ends with a strange burst in high-frequency activity. Both bursts, beginning and end, do not look seismic in nature. They're not monochromatic. But look at the actual signal that is being transferred through the seismic station. That's monochromatic, meaning contains one frequency and one frequency only. Notice the one frequency is at about 30.1 hertz and the second frequency is at about 18.5 hertz. Go back to the actually, let's go to the waveforms. Here's the look of it. Let's zoom all the way out. There it is right here. To me, this looks like some type of calibration pulse or maybe a jackhammer. I don't know. Actually, no, wait, a jackhammer would not be monochromatic in nature. Zoom all the way into the waveforms. Very spiky sine waves, very high frequency. Again, monochromatic, very monochromatic, meaning it's likely to be anthropogenic in nature. Meaning it's basically just a human-made event. This right here looks like some type of low-frequency event. But, yeah, no, I bet that's a teleseism. Yeah, I'm thinking that's a teleseism. So let's move on, shall we? First, we saw an earthquake right here at 1539 UTC. Let's go back. 1539 UTC. This occurred at 1630. So this one, so 1539, we did see an earthquake. We did see one right here. Very strange looking earthquake. Let's look at this one. Notice how the coda, usually the coda, the end tail of an earthquake, loses frequency, right? Like, for example, you see a big spike on the spectrograms, and sometimes you see it slope downwards in energy, right? We see that a lot with other earthquakes. This just stays in the middle. I mean, it doesn't really, the frequencies don't lower in the coda, which I thought was very intriguing. I don't know why. This looks much deeper than what they stated. Wow. Possibly much deeper. We did have a few more aftershocks after this strange earthquake. Again, very strange high frequencies. Very little lower frequencies. You noticing that? Notice that. This one did have some stronger lower frequencies right there, but basically, you know, that's what I noticed on the East Coast. A lot of earthquakes everywhere around the world have dominant lower frequencies a lot of the time. That's just what happens. I mean, not all the time. But on the East Coast, I noticed a lot of the strange earthquakes, especially the ones associated with strange booms, barely have any lower frequencies at all. They're just high frequency earthquakes. Now, that's obviously normal. It could be caused by normal earth processes, but I just thought that was interesting. So again, these are some aftershocks not being reported. So North Carolina likely had 1, 2, 3, 4, 5, 6, maybe 7. 6 or 7 total earthquakes today, in the past day. They're only reporting 2. Now let's go back to the event page for the other magnitude 2.6. Again, this 2.6 was at 0.8 kilometers in depth, and 321 people reported feeling it. But let's go to the first magnitude 2.6. Let's go to the event page. Again, this 2.6 occurred at 4.4 kilometers in depth. Let's go to the event page. And 708 people reported feeling it. Again, go to origin. Come on, buddy. I'm too fast for it. Quick arrival time once. This has a different closest station because it was farther away than the first earthquake I just showed. Let's do U56A, which is a broadband station in the N4 network. Let's check it out in Swarm. Here we have the data stream from U56A in the N4 network, which is a broadband station 00, location code. Let's turn persistent rescale off, set overlap to 95, if it'll let me. And I was going to do a 0.7 hertz high pass filter. Actually, let's just do 0.6, but I'm not going to enable it yet, because I want to see if there are any dominant lower frequencies in this earthquake. No, there are not. Okay, so let's just turn on that filter just real quick. Okay, here's the spectrogram of it. Again, no dominant lower frequencies. Again, very strange. On the East Coast, a lot of the earthquakes do not have really any low frequencies at all. A lot of the frequencies start around 2 hertz or so. This one's starting at about, let's see, 2.1 to 2.8 hertz. Very strange, very strange. Let's do a frequency extended 55 hertz, if that'll let me. Nope, it'll only do 50, but still. High frequency earthquake, normal tectonic event. Lasted a good amount of time. This is the one that was felt by many more people. Many more people. Looks like there's some background noise increasing, but I don't know what it is. It doesn't have dominant lower frequencies, though. Notice how the frequency band is staying around 4 hertz. Yeah, that is kind of lower frequency. But still, that's probably Telseism right there. Not seeing any other earthquakes associated with this first 2.6. Again, the other 2.6 that occurred closer to the coast, that one had many more aftershocks than this one. I believe the first 2.6 right here didn't have any aftershocks. Not seeing much at all. Zooming out. Yeah, not seeing much at all. So let's move on to one more thing just real quick, and then I'll be out of your hair. Then I'll be all done. Did anything else occur since I've been recording? Not really. Okay, so let's take a look at this earthquake right here. But it is so far north, I can barely get a good view of exactly where it is. So let's take the coordinates, shall we? And let's paste it into Google Earth. So let's paste the coordinates into Google Earth and press search. Will it search? Wow, look at that, guys. Look at that. Why did it do that? I don't know, but let's zoom out. This is the epicenter of the earthquake, guys. Wow, look at that. Look at that. The North Pole, the exact North Pole. Well, the magnetic field has been shifting. It's been moving. That's what's causing all the crazy weather lately, I believe. The magnetic field has been shifting far faster than it ever has been. But really, the North Pole is supposed to be right here. Right here. So we did have an earthquake literally hit the North Pole along this very large trench right here. There's Jan Mayen Island. Here's the Norwegian Sea. Going down here, we see the east coast of the United States right there. It's upside down, and then we have the North Pole right up here. Got Alaska right there. Got Russia. So this is the location of the earthquake right at the North Pole. So, how are they able to locate this earthquake? I doubt there are any seismic stations actually at the North Pole, unless Santa made himself one, but of course 0 people reported feeling this. Let's go to Origin and see what the closest seismic station was that they used to determine that this earthquake actually occurred. Arrival time on, that's why the closest one is 166.5 seconds away for arrival time. The distance is 11.69 degrees, so it is pretty far away, but still, they were able to record it. IU network, KBS station, broadband vertical. Let's check it out. Here we are in the seismic program, swarm with the data stream from the closest seismic station to detect the North Pole earthquake. Again, the North Pole earthquake that occurred today occurred basically right under the North Pole, guys. Well, at least where it should be. Let's turn persistor rescale off, set overlap to 95. Gonna do a 0.6 hertz high pass filter, but I'm not going to activate it yet. Not gonna activate it yet. When did they say this earthquake happened? 4.6 at 10 kilometers in depth. Again, the depth could be very wrong. It's 6:51 UTC, so let's go to 6:50, which should show up on here since it's 166 seconds to arrive on the station. Let's say it showed up at 6:53. Let's go to 6:53. 6:53. Man, I'm way off. There we go. Okay, right here. I believe that's it right here. Let's see. Let's zoom all the way out. That's it. Yeah, that's it right here. It's so tiny. Look how tiny it looks. Oh my god. 6:54. Yeah, 166 seconds to arrive to the station because this is the closest seismic station because they don't have any stations at the North Pole, really. So I'm guessing this one's probably in Greenland or something. Let's turn the 0.6 hertz high pass filter on. Barely, guys. Wow, barely can even see it at all. That's it right here. It's super weak. So let's do a high pass filter of 2 hertz. I just want to really draw it out. 2 hertz. There. There we go. Notice how that worked? Notice how the bottom half, see, that's what a high pass filter does. I love these filters, guys. And it drew out the earthquake. Very tiny, but again, under the North Pole. This is March 26, 2019's North Pole earthquake. Yes, it is. Alright, so one last thing, real fast. I want to check out the recent deformation for Yellowstone. So let's go to Web Services. Let's go to the UNAVCO. That is not architecture. What? That is not what I pressed. Web Services. There we go. Okay, now remember, if you guys want to learn how to make your own GPS deformation charts for anywhere in the United States, they're a lot better. I am telling you right now, if you want to see a period of like 2 weeks to 2 months to maybe even a year or so, then you need to make your own GPS charts. But if you want to see multiple years, let's say 2 years, 5 years, maybe even longer than a decade, I suggest you just use the online volcanoes.usgs.gov GPS deformation charts on there. The ones that are already pre-made by USGS. I believe you should just use those if you're looking for multiple years. But if you're looking for small term changes in the near term, then you really should create your own, guys. And again, just go to my website. Link is in the description box below. Go to the how-to drop-down menu and click the page that talks about GPS deformation charts. First, we're going to check the Old Faithful area in the Upper Geyser Basin, OFW2. The CWU Analysis Center, we're going to do NAM08. We're going to do from January 1st, 2019, T000000, to 2019-03-25, T010000. Again, I explained a lot of this in my GPS deformation video. Go to my channel or go to my website to watch it. Press try it out. Apparently this site was not working. It was not working for multiple days. I was trying to get GPS data, started getting a little concerned that I couldn't access it, then all of a sudden it came back online, thank God. So let's copy the link, open the link in a new tab, download the data, and let's check it out. Here we have Microsoft Excel and the GPS data open for OFW2 in the Upper Geyser Basin near where Old Faithful resides. Again, use std-dev-u, which will show uplift or subsidence. Let's check it out. Check it out, check it out. Highlight them all and only the numbers. Then you go up into Insert. Press Insert. Press Line Graph or Line Chart, 2D Line Graph. And there is your custom-made GPS deformation chart for OFW2, which is near the Upper Geyser Basin. I'm going to open this up like that, spread it all the way out. Okay, now I'm going to add a trend line. A trend line on Excel shows you if there's any growing or shrinking trends. Barely. Nothing at all. It shows a barely, slightly growing trend, but it is so insignificant. Again, these are in meters. 0.01 meters is 10 millimeters. Again, if you want to know what the millimeters are, it's super easy. Let's say, okay, you see 0.01 meters, right? Move the decimal 3 times to the right. So 1, 2, and then 3. So that would make it 10 milliliters. Millimeters, actually, excuse me. Then this would be 12 millimeters, 14 millimeters, 16 millimeters. So each bar, so from here to here, is 2 millimeters. That's it. Okay, so from right here to right here is 4 millimeters. So from right here to right here is 4 millimeters, goes back down. Slight growing trend, but I do not believe that's going to head anywhere right now. Again, I do believe caldera-wide uplift will begin again in the next 2 years, because we have not been at this level of subsidence, where the ground has been sinking for a while. We have not been at this level of subsidence since 2006, guys. Seriously, all you have to go do is look at the GPS deformation charts, which is what you use. Read chart labels. Remember, guys, always read chart labels, otherwise people are going to try to deceive you. In order to not get deceived, you gotta use chart labels and understand what you're looking at. But thank God my website helps you do that, and it's actually pretty easy to do. Do not let anyone tell you this stuff is hard. It might be a little bit hard at first, maybe take you a day to get down, but really, analyzing stuff and understanding their causes is much harder. But looking at the charts and understanding how to read the many charts and plots and everything that people give, that's easy. Do not let anyone tell you it's not, otherwise they're lying to you. And I do not like people getting rude or lying to my viewers. Just saying. Okay, sorry, had to vent a little. But again, not seeing too great of a growing trend, but again, we do see multiple millimeters. From right here to right here is about 4 millimeters. So nothing too crazy, a few spikes here and there. Not seeing much else. But again, if you want to see that we are at the lowest level of subsidence, since 2006. Go to volcanoes.usgs.gov. Select Yellowstone, go to monitoring, and then click the GPS deformation charts. Remember, they're the blue stars. You might have to do filter instruments and turn it on if it's not turned on. And then look at the line, the most recent data stream, and all the way back in 2006. And you will notice that we are basically at the same level as 2006. And we have not seen any major uplift since, 2014, 2015? But I do believe that since this is part of a breathing type of activity, with Yellowstone it goes up and goes down, it goes up and goes down. The last period of uplift was a little bit worse than the one before that. But think of this. Think of someone who's about to burp or sneeze or something, right? It inhales, exhales, inhales, exhales, inhales, exhales, and then all of a sudden, boom, right? I mean, all this uplift and all these earthquake storms aren't going to lead to just nothing, right? I mean, I'm not saying a super eruption is approaching, guys. I'm not saying that at all. I don't believe it is. Personally, I believe it could happen in my lifetime, contrary to what the professionals say, but I don't have any proof of that right now. None right now. But I do believe there could be some type of an eruption at Yellowstone. I mean, a lot of the stuff that's happened in the past, supposedly, the past 70,000 years, supposedly, is lava flows. So that's likely what we will see next. But then again, remember how much magma is down there, guys. And remember how it's not just one chamber with a tube leading to the surface. I mean, it's very intricate down there. There's a chamber, which they say is about 15% melt, which is too small for an eruption. But get this. The melt percentage for the magma reservoir, because remember it's a two-chamber system, I believe it's much, 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 much higher. The chamber and the reservoir, the chamber's the tiny guy. I'm not really worried about the chamber, guys. I'm worried about the reservoir that's sitting right under the chamber. And not only is the reservoir sitting under the chamber, but there's a mantle plume sitting under the reservoir. I mean, and they say it extends far to the southwest, going 1,500 miles deep. Isn't that crazy? So that means it's very unpredictable, and you don't know what will happen with Yellowstone. You don't know. It could erupt immediately, or it could not. You just gotta watch and be wary, and don't be worried, because there are many bad things that could happen to you before Yellowstone erupts. I mean, Yellowstone isn't the only supervolcano. You know about Long Valley Caldera? Long Valley Caldera is also a very dangerous supervolcano too, guys. And that one may be approaching an eruption too. I don't know. I'm not a complete professional, but that's what I certainly believe. Personally, I believe Long Valley will erupt before Yellowstone does next time, but you never know. Well, I gotta go, guys. This is the most recent GPS data for OFW2, Old Faithful, Upper Geyser Basin area. This is in meters. Again, from here to here is 2 millimeters. From here to here is 4 millimeters. Hope you guys have a great day. I will be back soon. My next video likely will be the monthly volcano update, unless something crazy happens at Yellowstone or another place or something. But yeah, thank you guys for sticking by, and see you guys later. God bless.